Hey Geometry, Miss Soli here. Here's 4.3. 4.3, that's not a good sign. And we are going to talk about one postulate and one theorem today. One's called SSS and one is called SAS. Get excited. What does it mean? All right. So before we jump into SSS and SAS, I want to define one kind of property of equality that you learned way back in elementary school. I'm sure don't remember the name of it. It's a really kind of oddball one, but we did not define it earlier in the year. It's called the reflexive property of equality. And I didn't define it because you didn't use it at all the last time we did proofs, but you're going to use it this time around. And what it says is A equals A. That's it. A equals A. So anytime I have two things that are equal, I can say that they're also like equal in length. If these two things are equal, they're also equal in length. All right, let's go ahead and dig into the side, or SSS, triangle congruence postulate. Postulate is a different word kind of for theorem. A postulate is one that doesn't really need a proof. It just makes sense. It just makes sense. It just is. And in order to do this side postulate, we're going to draw two triangles over here. Triangle. I'm going to orient them the same. Do your best to make them also look the same. Triangle ABC. Not bad. And triangle RST. Okay. And what the side postulate says is if all three side pairs are congruent, then the triangles are congruent. So let's look at that. It's going to look like this. If side AB is congruent to side RS, and side BC is congruent to side ST, and side CA is congruent to side TR. If you can prove to me that all three of those things are true, then triangle ABC is congruent to triangle RST. All right, let's do a proof. It has been a minute. We're going to go nice and slow. All right, so for example, let's draw this shape with me. If I have LKM, make sure you're labeling these in exactly the right spot. Yeah. And instead of like before I would write, here's what's given, I'm just going to draw my given information right on the triangle. I'm going to tell you that these two sides are the same. And I'm going to tell you that these two sides are the same. I would like you to prove that triangle KLM is congruent to triangle NLM. given on figure. Sometimes it'll say something like that with given information on the figure, or it'll write everything out for you. Okay, so proof. I'm going to make a little table where I've got my statements over here. Hopefully this kind of comes back nicely. My reasons over here. And remember, I'm going to always start with my given information. I'm going to end with my where I'm going. Like a proof will always give you the ending. You just have to tell the story, right? And I like to number these, line these up. So my first piece of given information is that KL is congruent to NL. KL is congruent to NL. That's given. It was on the triangle. It was printed there. And then also KM is congruent to NM. Sometimes these will be in the same statement, and sometimes they will be in their own separate things. Okay, now step number 3, I can say that LM, this one in the middle here, is congruent to LM because it's the same line. It's the same line in both triangles. It's the same line. That is why I did a little reminder of the reflexive property. It's the same line. Now, I have proved all 3 pairs of lines in both triangles are congruent, so I can now conclude that triangle KLM is congruent to triangle NLM because of the side congruence postulate. All right, next. Very similar. Maybe I'm going to do purple. Okay. The side angle side. Or SAS. Triangle congruence theorem. You absolutely do not need to remember which one's a postulate, which one's a theorem. There are going to be 2 postulates and 3 theorems in this unit. It does not matter which one. So let's say here I've got triangle. Let's go like this. Triangle X, Y, Z, and triangle D, E, F. Something like this, right? They are congruent by side angle side if side, let's say XY is congruent to side D. And the included angle Y is congruent to angle E, and side angle side, YZ is congruent to EF. Then triangle XYZ is congruent to triangle DEF. So that I could prove 2 sides and the included angle are the same, then the triangles are the same. All right, we've got room for, I'm going to do just a very short proof down here. It's not too long, but practicing our proofs is important here. All right, say I've got something like this. A, B, C, E, F. Sure. And let's say these two are congruent, these two are congruent. Prove triangle A, B, C is congruent to triangle F, E, C. All right. So in my statements and reasons here, statements, reasons, I'm going to start with my given information. So side AC is congruent to side FC, given. Side BC is congruent to side EC, given. So looking at this information, I know two of the sides are congruent. So I have two choices here. Either I can try to prove that this third side is congruent, so I can use side, side, side. Or can I prove that this included angle, the angle between two sides, is congruent? Yes, I can, using what type of angle pair is this? Angle ACB is congruent to angle ECF because they are vertical angles. Congruence theorem. And now when I'm deciding what to use, like what of the theorems to use, side, 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 or side angle, side, I want to look at just one triangle and see that I have on it, if I like kind of go around the whole thing, side, angle, side, and they're all corresponding and they're all matching. So then I can now say that yes, ABC is congruent to triangle FEC by side, angle, side.